Okay, let's dive right in. We've got a really interesting, almost sci-fi sounding story today.
Yeah, it's quite something. We're talking about a 53-year-old piece of Soviet spacecraft.
Exactly. Cosmos 482, specifically the descent craft part of it. And it's predicted to re-enter Earth's atmosphere around May 10th.
Which is pretty soon. And it's not just any old satellite part, is it? It's from a failed Venus mission.
Right. Like a ghost from the Cold War space race suddenly deciding to drop in, literally.
It's just fascinating how long these things can stay up there and then boom, an unexpected return.
We've been looking at a report in The Independent for this, and it cites a Dutch satellite tracker, Marco Langbroek. He flagged it on X.
Right, Langbroek does great work tracking these objects. It highlights this whole issue of space debris, but with a very unusual twist.
So our mission for this deep dive is basically to unpack this. Where did this thing come from? What might actually happen when it comes down?
And perhaps the most intriguing part, could it actually survive?
Yeah, that's the kicker, isn't it? A possibility that this lander, built tough for Venus, might actually make it through our atmosphere in one piece, or at least partially.
That's the really unusual aspect. Most things burn up completely. But Venus, well, Venus is a whole different ballgame, pressure-wise, heat-wise.
Okay, so let's get the backstory straight. This wasn't meant to be orbiting Earth for half a century. It launched March 31st, 1972.
1972, wow. That's a long time ago. Nixon was president. Watergate hadn't fully broken yet. Just to give you some context.
Its goal was Venus, but something went wrong, right?
Yeah, a technical failure. The upper stage, the bit designed to propel it towards Venus, malfunctioned.
So instead of heading off to another planet, it just got stuck circling Earth.
Exactly, in a kind of elliptical orbit, which is why it's taken so long for its orbit to decay to the point of reentry.
And it's not tiny. The report says the descent craft is just under 500 kilograms.
That's about, what, 1,100 pounds? So yeah, a substantial object, not just a little fragment.
Which brings us to the descent itself. The predicted re-entry is around May 10th.
That's the current estimate, yeah. These things can be tricky to predict precisely until much closer to the time.
And the speed. They're estimating around 250 kilometers per hour.
Yeah, about 155 miles per hour. That's the final plunge speed. But the initial encounter with the upper atmosphere is much, much faster, generating incredible heat.
The article even compares the potential force to a meteorite impact. Is that a fair comparison?
Well, in terms of kinetic energy, for an object that size hitting the atmosphere, yes. But a meteorite is usually rock or metal coming from much faster interplanetary speeds. This is orbital decay. Still, it's carrying a lot of energy.
And Marco Langbroek, the tracker we mentioned, he called it an unusual, uncontrolled reentry.
Which sums it up perfectly. It's old, it was part of a specific, ambitious mission, and nobody's steering it. It's just falling.
Okay, let's talk survival. This is the really wild part. It was built for Venus.
Right. And Venus's atmosphere is incredibly hostile.
Mm-hmm.
We're talking surface pressure about 90 times Earth's, and temperatures hot enough to melt lead.
So the engineering had to be intense.
Absolutely.
Yeah.
You need a very robust heat shield, incredibly strong structure to avoid being crushed. Think deep sea, submersible level pressure resistance, but also heat resistant.
And because of that design, Langbroek gives it a small chance of surviving Earth reentry.
Exactly. Most objects break apart and burn up because they simply aren't designed for that kind of stress and heat upon reentry.
Mm.
But this thing, well, it was designed for extreme stress and heat.
So Earth's atmosphere, while destructive, might be less destructive than what it was supposed to handle on Venus.
Potentially, yes. The peak heating and pressure during Earth reentry might be within the design limits intended for Venus. It's like it was, over-engineered for our planet's reentry conditions.
It just seems so counterintuitive. Built for hell, survives a trip through purgatory, maybe?
That's a good way to put it. It's a testament to that Soviet-era engineering for the Venera program, which was actually quite successful in landing on Venus eventually.
But it's not guaranteed, is it? The report mentions uncertainties.
No, definitely not guaranteed. There are big question marks, like the long, shallow reentry trajectory.
What does that mean, a shallow trajectory? How does that affect it?
It means instead of plunging straight down, it comes in at a glancing angle. So it spends a longer time in the upper atmosphere.
Does that make it hotter or cooler?
It might mean the peak heat is slightly lower, but it's exposed to hot temperatures for a much longer duration. Sort of a slow roast versus a quick broil.
And then there's the age, 53 years in space.
Right. Radiation, extreme temperature swings between sunlight and shadow. Materials degrade over time.
Yeah.
Has the heat shield become brittle? Are there microcracks? We just don't know how well it's held up after all this time.
So Venus-proof design, plus point. Age and shallow reentry? Question marks.
That's a good summary. It's a race between its original toughness and 5 decades of wear and tear, plus the specifics of how it finally falls.
Okay, the big question everyone asks. Where is it going to land?
Well, that's the million-dollar question, isn't it? The short answer is it's way too early to say with any certainty.
Why so difficult? We can track it, can't we?
We can track its orbit, yes. But predicting the exact point where atmospheric drag finally pulls it down is incredibly complex. Tiny variations in atmospheric density, the object's orientation, how it tumbles, it all affects the final trajectory significantly.
But we know something about the potential area, right? Based on its orbit.
We do. Its orbital inclination is 51.7 degrees.
Okay, translate that for us non-rocket scientists.
Sure. It basically means its path around the Earth goes as far north as roughly 52 degrees latitude and as far south as 52 degrees latitude.
So it could potentially come down anywhere within that huge band around the Earth.
Exactly. That band covers a vast amount of the planet, including many populated areas, but also vast stretches of ocean.
The report says it's likely to hit water.
Statistically, yes. Oceans cover about 70% of the Earth's surface, and a lot of that falls within that latitude band. So odds are it splashes down somewhere remote.
But there's still that small chance it might thud into land.
Right. It's less likely, but definitely possible. And that's obviously the scenario that gets more attention.
So connecting this back for someone listening, why is this more than just, another bit of space news?
Well, I think it's a few things. First, it's this tangible piece of history, isn't it? A direct link to the Cold War space race, literally falling from the sky. You can almost touch that era.
Yeah, it makes that history feel very present.
And second, it highlights the legacy of what we put up there. Space isn't empty. It's full of objects we launched decades ago, and sometimes they come back in unexpected ways.
It's definitely not your average satellite reentry. A 53-year-old probe possibly surviving, that's unusual.
Very unusual. It speaks volumes about the kind of robust engineering needed for planetary exploration back then. It makes you think about what else might still be functional, or partially functional, up there.
And just the sheer unpredictability of it all.
Yeah.
We know roughly when, we know a huge potential area where, but beyond that.
Exactly. It's a reminder that space and the physics of reentry still hold unknowns and surprises for us. Will it be a fiery streak? Will a piece actually land somewhere?
It's that element of chance that's captivating.
Absolutely. We can calculate orbits, but the final moments of an uncontrolled reentry always have that element of uncertainty.
Okay, so let's pull the threads together. We have the Soviet-era Venus lander, Kosmos 482.
Launch 72, mission failed, stuck in Earth orbit ever since.
Predicted to re-enter around May 10th.
And the really remarkable part, because it was built so tough for Venus.
It might actually survive re-entry into Earth's atmosphere, at least partially, which most things don't.
Right. While the most likely outcome is a splashdown in the ocean, we can't be sure where or if any part will survive the plunge.
I think the single most surprising thing for me is just that idea, a machine designed for Venus facing Earth and possibly winning.
It really flips the script on what we think of as extreme environments, doesn't it?
It definitely does. So, wrapping up, thinking about this, it makes you consider the whole legacy of space exploration,
Even the missions that didn't quite work as planned can have these incredibly long, unexpected afterlives.
Decades later, a final fiery chapter, and it leaves you wondering, what other forgotten pieces of history are still circling above us, waiting for their moment to return? Something to think about.